Okay, this is a continuation of the discussion on voltage dividers, hopefully this time with a little bit of a better example of how they might be used. So I've got the same setup as yesterday. We have on the Electronics Explorer board, we have the three resistors in series, potentiometers in series. And so the voltage is coming in along the power rail. I've got 6 volts in, feeds into this first potentiometer, and then we just continue along to the next pot, and then along to the next pot, and then back to ground. And then at the input of each of these pots, we're going into the scope channels. So the first pot in scope 1, second pot input into scope 2, third pot input into scope 3, and then the ground is into scope 4, just so that we see that ground level on the scope. And when we look at the scope, like we were talking about yesterday, we have 6 volts at the input of the first, 4 volts at the input of the second, 2 volts at the input of the third potentiometer, and then 0 at the output of that third potentiometer. So there's a 6-volt drop across those three components, the three potentiometers. And as we were saying yesterday, because of symmetry, the drop across the first one is 2 volts, across the second one is 2 volts, across the third one is 2 volts. So we should recognize that the resistance of each of those pots should also be symmetric or equivalent. So we're going to look at that real quickly. I'm going to first just turn this off, and we'll look at the resistance of those three potentiometers over here on our BK Precision multimeter. So I'm just going to look at this resistance for each one. We have 330 ohms on the first one, 330 ohms on the second one, 338 ohms on the third one. So they're pretty much equivalent. And then the drop across the whole thing, of course, is 992, or almost a kilo ohm, across those three potentiometers. I'm going to take these pins out so we can go to the next stage of this little demonstration. So we have about a kilo ohm, about 1,000 ohms across those three. And if we hook up again and get this thing started, we'll see that 6 volts across a 1,000 ohm resistance gives us this 6 milliamps that we're seeing of current across the entire system. That's being shown on the fluke meter. And then if we adjust, well, we did this yesterday, we adjusted various pots. Like if we take this first pot down to 0, we still need to have a 6-volt drop total across from the input to the output, or from the input to the ground. And so we still have symmetry, but it's now the second pot with 3-volt drop, and then the third pot with the 3-volt drop. And because we took this first pot down to a 0 resistance, the overall resistance dropped, so we have a higher current flow. I'll take that back up to where we were before, roughly, by making that a kind of a symmetric drop across the three. And then the next part of this is just to show how we can take this voltage divider and then use it to feed other parts of our system. And that's being mocked up here with some additional potentiometers. And now we're going to take some LEDs and hook those up. And this would be mocking up another part of the system that is going to be taking as their voltage inputs the outputs of these voltage dividers. So now we have 3 LEDs, and then we'll change the input from just a steady voltage to a waveform. So now you can see on the scope, we basically have a sinusoidal waveform that's being divided at different levels by these 3 potentiometers. And what that means is that the threshold voltage for lighting up the LEDs occurs at different times, as those waveforms have different levels. So if I were to stop this right there, for example, you can see that the first potentiometer has already reached 4 volts. The second potentiometer is close to, say, 3 volts. And then at this point in this stopped waveform, the third potentiometer hasn't quite reached 2 volts, so its LED is not lit up. So we have the first one's lit up, the second one's lit up, but then the red one is not lit up. So we can use that voltage divider to control the timing of when the LEDs light up just by virtue of that voltage divider setup. So that was the idea of this demonstration, to kind of show a more dynamic usage for a voltage divider. Alrighty. All right, that's it. Speeding this up so you can see what's happening to the current. That's it for this demonstration. Thanks for watching.